Today we'll be doing something different. Recently, I had this idea that can a neural network help to decode like a certain message that has been already scrambled up. Okay, so let's see. So you see over here. So this one is okay. Let me just ignore this code here. These are some sample code. Okay, so a neural network, a message has been encoded by a certain scheme. Can a neural network decipher it? So the message can be, let's say we give it like characters from A to Z, okay, and then the scheme can be like shifting by X, like we shift, like for example from A we can shift to like C. Yeah, so we do have the X here and then we can shift it. Then basically to decode it we just need to unshift it. So this is something like a ciphertext. I think this is called Caesar cipher. Okay, I shouldn't put these brackets. Yeah, so this is the very basic form of shifting and decoding. So let's just see whether or not the base form of a neural network can solve it. And yeah, to make things easy, because I'm not using like a graph neural network, I'm just going to use some linear layers. To make things easy, maybe what we can do is we can just set the message length to be constant. Yeah, maybe 6 or maybe 4. Yeah. Okay. Right, so let's generate our data first. So, okay. So I have this sample code down here that I just put here just to let me see like how the TensorFlow thing works. Okay, so maybe what we should do is we should just follow similarly, something like this. So we need to generate data. So like the data. Okay, so like we have alphabet. Okay, and then what we will do is we just take from the alphabet some data from it. So like maybe we could just have images equals to, okay, it's not really images, but input text equals to, so we need to choose over here. Okay, so how do I put it? Input text equals to like that, maybe like 60,000. We give it 60,000 just like mness has 60,000 also. Okay, so we will have to put in the, okay, so I guess I'll import numpy. I'm thinking of using mp.random.choice to just choose a certain sample. Okay, let's just print the first 10 to see whether it's okay. It must be one dimensional or higher. Ah, okay. I guess they want me to put this in an array. Yeah, so I guess if we do a random number thing, it would be easier. Because like if you do random dot choice, you need it to be a list. So random number generator. So over here we can use random, I guess. Ran ints like this, random. Yeah, like this. I think NumPy has also a random dot ran in. So you can just put like low is. So for instance, one. Okay, what's the first number? The first number is low and high. 3, 5, 10. Okay, this you can put many different numbers later. I guess if I put like two without the higher bound, then the low will be, yeah. If low high is none, then it will be here. Yeah. So what I would do is low to high. Okay, so we can put the highest number there. Okay, so we can just do this. Alphabet. Okay, mp.random.choice. Actually random.ran in len alphabet. Something like this. Yeah, something like this would be good. Yeah, so we can see that. Oh, okay, then we need to like times 4. So maybe we also have a parameter called length, with length of the message. Yeah. Okay, so we have this. Okay, now this is not that great because the is basically using the same thing 4 times. Okay, so what we should do is we should do this. Okay, 4 times like this. Okay, we can do this and then we will get like that. Okay, which we then can join. Okay, using this. So we can see that we have a few input texts like this. So these are the original texts that we have. Okay, so these are all randomly generated. And then after that, what we need to do is, okay, we then need to like, okay, maybe I do 70,000. Okay, 70,000, just like MNIS. MNIS has 60,000 training images and 10,000 tests. So maybe we do 70,000. And then what I need to do is I need to do a cipher. So what we'll do is the output text. Okay, so output text, what we do is we need to do a certain shifting of this input text. So let's define our shift here. Uh, Maybe let's put text and shift. Okay, so what we do is we need to shift for every character in text. Okay, what we do is we do a shift. Okay, okay, we do an in char plus shift. Okay, and then we do a character for that. Okay, so what we need to do is actually there's an easy way to do this. We can take the alphabet like this. Okay, and we just multiply by 2. Hey, hi, Omniscient. Yeah, doing good. Yeah, recently been doing a bit more of reading up in terms of like deep learning stuff. So yeah, I'm streaming a bit of that now. Yeah, in the future we'll be streaming a little bit more. Yeah, tomorrow is the coding game bot challenge. So I intend to stream that as well. Are you taking part in the bot challenge tomorrow? I think it's tomorrow, right? The 21st April Spring Challenge. Yeah. So yeah, it's been pretty fun. I'm learning quite a lot of stuff. Actually, I'm quite interested to see if the neural network can do this. Honestly, I didn't try before I started streaming. Yeah, this is something that I just thought of, and then like I thought, okay, why not just do some live coding and see whether it works. So yeah, you will see live firsthand with me whether this works, whether neural networks can do this. Okay, now we are. This is like a coding game challenge. Like you have this Caesar cipher, and you need to decipher it. If we do by algorithms, it's kind of pretty standard, which is what I'm going to do now. I'm going to do by algorithms now. So yeah, this is if you want to do by algorithms, you have to do something like that. Okay, I'm just thinking that I can just do like my shift over here. So like this is my alphabet, right? So I could do like alphabet shift, yeah, so that we can just take the shift, okay, which will normally be just a positive number. Okay, so we can do like that for character in text, out plus equals to shift. Okay, so if we do the index, you will return the first index of the element in the list, okay, which in this case should be if the element is not found, a value error is raised. So I don't think I want to use index. I'll probably use find because find doesn't raise a value error if I remember correctly. Yeah, we can use find, I guess. Text dot find, yeah, returns -1 if it's not found. Okay, good. Yeah, like that. And then we return out. Then we just append the shifted input text. Okay, so let's see whether this works. Oh my, it's taking a while to shift the text, I guess. Oh, I did it wrongly. So like I appended the whole thing. No wonder it took so long because it's appending the entire list. So like it's doing exponential increase in the amount of data. So yeah, let's do this. Why are you scared? It's fine. Yeah, things are okay. Oh, I think I forgot to shift. Okay, let's just shift it by 3. Object is oh, object is not callable. Hmm. This is this is not Okay, let me just print out this to see. SSDG. Okay, yeah, yeah. Okay, let's see if we do it like that. Int object is not callable. Oh, okay. I guess I didn't update this yet. Shouldn't have any impact. Int object is not callable. That's weird. Because if I put it here, it works. Hmm. Yeah, I'm trying to use like maybe the neural network to decrypt it. Yeah. So that's a very simple algorithm. That you see the neural networks. The problem is it's probably only used for computation. But if you want to do some algorithmic stuff, it'll be difficult. The encryption algorithm is very simple for this case. It's just a shift. Yeah. And we just want to see whether the neural network can decipher it. So yeah, this is something that I haven't done before. And let's just see whether it can decipher. Yeah, just experiment with it, tweak the architecture a bit, see whether it can work. Right now, I'm having problem to generate my data because like somehow it's not working. I'm not sure why, but I guess if I put string, I'm not sure why this is not a string. This should be a string. I don't know. I mean, okay, looks okay now. See over here, they put in object is not callable, which is very weird. Okay. Okay, let me just try. Shift input text 0. Oh, okay. So it's working if we do it like that, but somehow it's not working in the loop. It's working here. For this case of neural networks, just the pure vanilla one that I'm doing right now, it is of fixed length. But if you want dynamic length, I think it is possible also with graph neural networks. Let me just type it here so that you can, yeah. So graph neural networks is quite an active area of research right now because it allows for dynamic length to be implemented as well. Yeah. Okay, but right now I'm still very irritated because like no, you see it's working here, but why is it not working here? Oh, I caught the variable called shift. I know already. So that's why it became a 0. I shouldn't name my function the same as I shouldn't name my function the same as the variable. Rookie mistake. Okay, let's see. So actually I think this is okay. Okay, let's just print out here. Yeah, that's the issue with neural networks. So it takes a lot of training data. Yeah, which is something that I'm actively researching in, because like I feel that there's a way to make it use less data if we imbue it the right structure in the model. So that's my research focus right now. This one is related, similar to what I'm trying to do, but this is just more for fun right now. Yeah. Yeah, you see now I haven't even coded the neural network, and the code is staring back at me, telling me that I'm doing it wrongly. I mean, I have half a mind to just copy and paste this thing right here. Yeah, because I'm not sure why the function is not working. Mm, I mean, it's working right now. If we do it like that, this is working. I'm just not sure why when I append it here, it doesn't work. Oh, oh, you see, I I put the shift here as a number. No wonder they say it's okay. Okay, I get it now. Gosh, that was really quite stupid of me. Yeah, that was quite stupid of me. Okay, so we have generated our training set already. So we just do four of them. Okay, and then now what we want to do is we want to see whether we can create a neural network that can decipher this. Okay, so what is the neural network here? Okay, but before that, we should split this into training and test sets. So train text, train. Okay, we just call it train in and train out lah. Okay, uh, test in and test out. Actually, I don't need to do this because I can just slice the array later. Yeah, we can keep it as this. So this is my array. Okay, and what I want to do is I want to create my neural network now. Yeah, you're right. It's about 15% of the data of all possibilities. We can't possibly give it everything, right? That will be kind of, I would like to use the word kind of lame, right? Because if you give it everything, you might as well just brute force everything. Yeah, which is not what we want. We just want it to give some samples and hopefully learn it enough to extrapolate to some other unseen data. Yeah. Is it better use 0 to 25 for input? Oh yeah, yeah, yeah. We will need to do some form of a mapping from like the numbers to the embeddings later. Yeah, because like the neural network doesn't accept letters as their input. You need to convert it to a number. You're right. Yeah. So inputs will be the letters, which will be converted to numbers. Okay. Outputs will be will be probability distribution for each letter. Then we will just take softmax and get the max. So what the loss function will be, the loss function is the loss function will be the softmax loss. Sorry, will be the cross entropy. Okay, so let's do it. I like to just like maybe copy this code and edit from here. Or maybe I just do it here like that. So instead of doing this data set, we can just get like Okay, we need to firstly, okay, we need to firstly have the input here. Maybe what I'll do is I'll do a very simplistic mapping first. Okay, I mean I could do a one-hot encoding to map the inputs for this. Okay, but what I'm gonna do right now, I'm just going to do a very idiot proof thing. Yeah, I'm gonna do this very idiot proof thing, which is just converting the letters to maybe the index. Like I convert A to 0, B to 1, C to 3, C to 2, and so on. So let's just convert the letters to index. So like over here, so basically the output can have up to 26 indexes. Okay, so let us just do the input. So when we do this input, we want to map it to a certain number for the inputs. Okay, this model wouldn't cut it if you use like sequential like that, because we do have multiple losses over here. Okay, so we kind of need to do like some form of functional method. So maybe we'll just do like that: model equals to inputs equals to, so the input, okay, we will have a shape of 4. I think it's defined like that. Yeah, so after that we will then run through the, okay, maybe I just import input flatten, then what else. Okay, we just keep it for now like that. So inputs will be input, the shape is, let's see, input. Yeah, so we need to do the input first. Input shape excluding the batch size, so it's like 32 comma. Yeah, actually neural network is very powerful. Yeah, because it is like fitting the curve kind of thing. Shape equals to like that. Okay, I'm gonna do something like this: model xy. Okay, so the shape is 4. Okay, because we have only 4 of this. Okay, so we kind of need to like map our input and output text to a readable form for our network. So let's do the mapping now. What if we can just do like dot apply on the list? Can you do a dot apply on the list? I can apply it, or actually I can just do map. Yeah, I can map a function onto it. Yeah, dot apply is for like if you want to do something to do with pandas. Yeah, data frame, you can do dot apply. You can just do map. Yeah, so we could do a map. So we can do a convert to num text. Okay, for, okay, so we have the output, each, okay, maybe character, alphabet dot find character. Yep, so we have this convert to num. Then we can just put like input text, map the convert to num to input text, new what do you call that, um, in input process. Okay, there's no shape here, but we can just check what is the 57220. Yeah, oops, that's a bit too much. Yeah, so it looks like it has mapped correctly. So 57220 is here, 57220, which is correct. So the length of this input process will be like 70,000. Okay, that's all right. Okay, so we can just do this. Okay, so of course we can also do like one hot encoding in order to like make the neural network learn more in terms of like you have like a list of numbers and then you just put one at the target character. Yeah, but I just want to do something very very simple. Let's just stick with this. So we just map the input. So this, if you like do like um, for words, this can be something like the embedding space for the word. But in this case, the character we just have a number 1 to 26. Oh, sorry, 0 to 25 to 0. Okay, so we have this processing. Okay, the input shape will be 4 now. Okay, and then we have like x equals to okay, so we do it very simple. Okay, from this 4 here, we just do like a dance, maybe 1,000. Yeah, we just do a relu activation, and then this one is from inputs. Okay, and then what we do is we have then another one. Okay, so we need to have separate outputs for each of the numbers. So like for I in range 4. Okay, so in this 4 is probably length. For I in range length. Okay, we have Y. Okay, so Y dot append. Okay, okay, so we have a length here also. uh so which is length alphabet. Okay, 26 actually. Yeah, so we do this, we append this Y, so we have a Y array with all this appended. Okay, so we can just take away this. So then model equals to model, inputs equals to inputs, outputs equals to Y. So if you look at the TensorFlow Keras model method, you can see that you can do something like that. You can do multiple inputs and outputs. So inputs is the input of the model, output is the outputs. So you can do a single output or you can do a list of outputs also, if I remember correctly. So let's see functional API example below. Yeah, you can do outputs. Yeah, I'm pretty sure it can do multiple outputs. Yeah, so there are, yeah, 4 outputs for each letter. Yeah, and then we split into 26 nodes. Okay, because the outputs here uh, over here, this goes to the length of the alphabet. So yeah, we can do like that, and then we can then compile with the cross entropy. Okay, so loss, we need to specify 4 losses times length, maybe because there are 4 of this. Yeah, we can just do like that and just see whether it works. Then we can fit in. Okay, so maybe we can put like train input equals to input process until 50,000, like that. Train input, test input, okay, train output, test. Yeah, let's just okay. So we have this. We feed in the train input to the train output, then we evaluate the test input to the test output. No module name TF. Oh, model is not defined, of course. I think model is in TensorFlow.keras. Yeah, so I need to import this one. Output tensors must be the output of a TensorFlow layer. Found dense object. Wait, which one is this? Okay, let's just see what y is. 1, 2, 3, 4. Yeah, looks okay, right? I mean, looks like there's 4 output. Yeah, I mean, you have to get some errors once in a while, right? But you'll be surprised, sometimes in coding game, I just like program something and then boom, one shot, one kill, especially in like fastest mode. Yeah, so I guess if you are familiar with it, the more familiar you are, the less errors you have. Yeah. That's why I like to sometimes code live, because I guess if you don't see me do this, you might think that it's a very easy thing to do, but actually it's not. Yeah, it takes quite a lot of effort. Okay, so we do have like 1, 2, 3, 4. We do have 4 of them. Okay. Let's see. Mm, okay, there's some issue here. The issue is that they don't recognize these outputs as like that. Oh, I know why. I know why. I know why. I forgot to put X over here. Yeah, so it kind of did not have anything from the forward layer. Oh, now it's running. Yeah, now it's running. Okay, invalid train function. Okay, let's see what's wrong here. Model.fit train input train output epoch equals to 5. Okay. uh Logits and labels must have same first dimension. Got logit shape 32, 26, and label shape 1 to 8. Okay, so what happened is that for the labels here, I need to split them into 4 parts. Okay, because I have 4 outputs in my model here, right? But my test output currently and my train output currently doesn't have the basically it needs to be split into it needs to be split after this convert to num. Okay, this individual part here needs to be split into like, how do I put it, you need 4 different outputs in order to match, because your model has 4 outputs here. So let me see what I can do about it. Okay, maybe now is a good time to like do a reshape over here. We could convert this to a numpy array and then we reshape it, or we could just split this list here. Yeah, so that instead of having a full text, yeah, they evolved the Stone Age to almost non-human level. Yeah. You'll be surprised how much these weights can learn. You'll be surprised. They can learn actually a lot. And yeah, I mean, if you're interested to know more about how they work, actually, I'm currently giving some tutorials on it. Yeah, it's actually on my YouTube. Yeah, but this one is not. This one is something that I just thought about today. I just had a brainwave today, and I thought that okay, let's try to implement it. And here I am. Okay, yeah. So not the issue here is that I have an output that has four length four, and my output process currently, if you look at output process, the output process right now is, oh, it's already mapped into four already, is it? Oh, okay, it's already mapped into four. Okay, so what's the issue here? Got logic shapes 32, comma 26, and label shape 128. I see. Okay, so the output shape here, okay, it should be one hot encoded. Okay, it should be one hot encoded because of the way I defined the output. The output here was defined as a dense, and I dense of 26 characters or 26 outputs. So over here, you only have four outputs, which did not match what was required. So I actually needed this to have 26. So let's just use the TensorFlow one hot tensor and encode it. So let's see how this works. Okay, so we have the indices like that and the depth, and then we have the output like that. Okay, looks easy enough. Aha, there we go. So we have like that, like that, like that. Yeah, so in the end we use one chord after all. Yeah, so yeah, I guess in the beginning the shape here is not just 4 anymore, it's probably 4 comma 26. Okay, because we do have like one hot encodings for all of them. Yep, so maybe we could do this. Yeah, so we can then get the shape ready because I make them into, so it's 50,000 here, and then like, thank goodness there's one hot encoding from TensorFlow. Yeah, I mean it's easy to implement it yourself, but you know sometimes you're just it's nice to use pre-built stuff. Okay, so oh, okay, actually it should be 60,000, I realize, because we have 70,000 input sets. So we do 60,000, we can actually have a validation split of. So let's do a validation split. In model.train, we can do a validation split. Keras. Yeah, so I think it's a validation split over here. Yeah, validation. Oh, we can also do validation data. Okay, no issues. Okay, no issues. I mean, we can also do validation here if you want to. Like that. Yeah. Let's see. Roadside down. You said you played around with this stuff a little bit. Currently more on web dev. Yeah, that's nice. In fact, I'm currently learning web dev. I actually want to like push out some of this practical neural network products, like using some cloud backend and then just use Flask or something to push it out. Yeah, I'm still learning how to do it. or Django. Yeah, Django works well also. Yeah. Okay, so now let's go back to our network. Okay, so our network has a shape of 426 because it's one hot encoded already. Okay, so I guess what we want to do now is we probably want to flatten the first layer. Okay, because we do have a dense 1024 here, but we probably want to flatten the inputs. Flatten layer just basically means make all into one straight line. So then we can do this. Okay, let's see whether it can run. Okay, oops, still cannot. 32 comma, but it's getting closer. 32 4 versus 32. Okay, and where is this from? Train input, train output. Oh, I forgot to put the validation data, so let's put it in now. Thirty-two comma 4 versus 32. Okay, so I did put my outputs here. My train output. What's my train output? My train output 50,000 for. So if let's say I were to just take the first one, it's 4,26. My model output is like this, but my model output would be appended the dense for four of them. Okay, let's just see what's my model. Flatten, dense, 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 dense. The output is none, comma 26. There are four branches of output. Okay, let's use the plot utils in Keras to see this. tf keras.utils.plot model. Too many windows. Okay, let me just put these few lines in a separate block. tf.keras.utils.plot model. Oops. Not sure why it doesn't load. Oh else. Yeah, I think this is good enough. Yeah, you can see here. I'm just wondering why it did not work. Currently work in the public sector. Yeah. Yep. So Omniscient, you are web dev also, is it? Based on what you type in the chat. Yeah. Okay, so let's continue. Incompatible shapes 32 4 versus 32. So I'm not too sure where is the issue with this. The issue is definitely here. I mean the stack trace is here. No, I'm not exactly surviving. I'm currently still a PhD student, so yeah, things are a little less like real life right now. Yeah, but eventually, yeah, you need to have practical applications to survive. If let's say you want to do ML or AI, you need to have something that the market needs. If not, it'll be hard. If not, I mean, I guess if you have something that researchers need, then academia is fine as well. Yeah. So ultimately, the market is driven by demand and supply. So I'm pretty sure there will be a market for some. I mean, especially for coding skills, you just need to find the right market. Yeah. I actually do like to try to create AGI. I'm a fan of DeepMind, to be honest. Yeah. But I don't have the compute to re-implement what they did. And I also find that the deep reinforcement learning era, or the stuff that they do there, is currently very resource intensive, and it's quite stupid also. The AI really needs a lot of examples to learn. I myself have re-implemented Alpha Zero. It took 1 month to learn a very simple game such as tic tac toe. It took 1 month. But of course, my tic tac toe board size was larger. Yeah, so if AIs are going to take over the world, I think not so soon. Not so soon. Yeah, not with the current AI. You still need to do a bit more work. But it's definitely impressive. Yeah, the AI right now is impressive. Okay, but AI or not, I right now I still can't figure out why there's an incompatible shape here, because based on what I see, okay, I should have a tensor shape of 4 comma 26. Okay, and then yeah, maybe I should concatenate my outputs. So I have 4 outputs here. Yeah, maybe I need to split my output into 4 parts. Mm, okay, let's just generate a length of 1 and see whether it kind of works first. Okay, so if the length is 1, as you can see, everything is 1 now. Okay, input 0 is incompatible. Expected shape 426 got 126. Okay, so over here I didn't change my input layer to the length, so let's do it. Length. Okay, so now I just basically shifted my equation to just only have like 1 character. Okay, let's see here. Logits and labels must have the same first dimension. Got logit shape 32, comma 26, and label shape 832. I mean, it should be a 26 here, right? The 26 output. I guess train output is fine. Unless I put my train output wrongly. Train output is here, 50,000. Yeah, that's correct. Logits and labels must have the same first dimension. Yeah, I need to think. Oh, so because 32 times 26 is 832, right? Yeah, I mean somewhere this is not the label shape is 832. Okay, I mean my batch size is 32, so if the label shape is 832, it means that they sort of concatenated my labels. Okay, I know how to do this. I think it's something to do with this part here. So maybe instead of doing this, okay, I mean just to try it out, let me just do it. Okay, let me just write another one. Okay, let's just do something like this first. Okay. Oh, it's okay. It's not the issue of this. Okay, it's not this issue here. Okay, the issue was with the one at the back. So this one is fine. The issue is with the data here. So maybe what could be done is instead of 1 comma 26, I could reshape it to like, okay, let's just try this. All my outputs, okay, train output, val output, test output, all my outputs, I do a reshape. Eager tensor has no reshape. I thought there was a reshape. Oh, I need to call it like that. Okay, no big deal, no big deal. Okay, so now the issue is that the output is given 832, got logic shapes 32 comma 26. Hmm. Yeah. Sorry, Omniscient, what do you say? I wonder if the performance of combining four outputs into a single number concatenated into a single number. That would be worse actually. Because now what I'm doing a classification for each of the four outputs. So if we combine all four together, it'll be a combinatorial explosion. Okay, which means that you need to do 26 to the power of four possible outcomes. So right now, by segmenting into different characters, I'm actually limiting the amount of outcomes, which will make the model perform better. Yeah. So, but right now there's an issue with the way the model is outputting because it's not seeming to train here. There seems to be an issue here. The label shape is 832. The logic shape is 32, 26. Both are actually the same. Okay, both are actually the same. 32 is the batch size. Okay, I'm just not sure why the label shape became 832. Okay, as I said, I haven't really tested this before, so maybe it might be because of this. Let's take a look at model.compile and take a look. If not, I have half a mind to re-implement the whole, re-implement the entire model function. Okay, so you can do like this: loss one, loss two, loss three. Yeah, like that. Yeah, if not, I might just have to do my own custom layer for this. So yeah, I still think this is correct. I still think this is correct. The structure is correct. Okay, the only issue is the loss here. Somehow it seems to not let me do. Okay, let's say if I take away the length here. Okay, I just do like that. Can it work? No, so it's not the issue with the loss either. What do you mean by that? If we can make an NN to decrease by one. Yeah, I think the structure of the neural network is the crux of solving the problem. So like a lot of modern architectures, they use like CNNs, graph neural networks. They try to imbue some form of human knowledge inside the model in order to process the data better. So ultimately, it's all about how you process the data. Actually, I just can't believe it that I'm getting stuck here Yeah. Okay, what happens if I just put batch size is 1? Will I get a problem? Yeah. Okay, my label shape is 26. Somehow they concatenated everything. So perhaps what this means is that maybe my train output, I need to reshape again. Yeah, maybe I should use the reshape method. Okay, let's just try. Let's just try. Okay, tf.reshape tensor, comma, shape. Okay, I cannot reshape in place. I have to use this very long form. I have to use this. Okay, let's try the reshape. Okay, it looks like the reshape is the problem. So let's just reshape it. So over here, I will do, to make it dynamic, I should do like length times. I should just do this. Okay, then maybe I'll do the same for the rest. And then I'll do the same here. Okay. Expected end of file while processing. Oh, did I put it wrong? Okay, looks like my brackets didn't match for one of them. Okay, this one. Okay, so now my output is 26, 26, 26. All right, what's the issue now? Logits must have the same first dimensions, 32, comma 26, and label shape 832. Yeah, this is so irritating. I mean, like, I already have the right dimensions actually. Yeah, I feel like I have the right dimensions already. Like, but then because of the batch size over here, then the dimensions are wrong. I see here's 32, comma 26. Yeah, so what I think needs to be done is, yeah, I'm pretty sure this is correct. I'm pretty sure this is correct because I've done something similar and this kind of works. Okay, the only issue is now why this logic shape don't match. Okay, so this is something that needs to be sorted out. I mean, could I just try batch size as 1 and see if it works? One 26. Yeah, I already changed my shape. I changed already. So it means that the output here, the shape is wrong. Mm, okay, the labels is 26, comma. The logits is 1, comma 26. So the logits came from here. Yeah, so this part here has the batch size and it has 1 comma 26. The logic is 1 comma 26. Okay, but if let's say I don't do batch size is 1, what will happen to my logits? My logits will be 32 comma 26. So this part here in the neural network, this part here is giving us 26 output and then the batch size of 32, but then my labels is giving me shape 832. So what this means, I should change my train output. But I've been trying to do that. I mean, I've been trying to change my train output already. So this gives me 26. Mm. Oh, don't tell me I shouldn't have done this. Okay, just put this like that in case I want to revert back next time. So I didn't expect to get stuck here actually. Yeah, I thought the model was quite straightforward. But TensorFlow can have some perks that you never expected. So you see this label shape is 832. Okay, I have 1 comma 26 here already. But somehow it's not being somehow the way that it multiply with the batch size is not done correctly. Okay, I know why. I know why. Okay, I need to sort of split my. Okay, right now it's 1 comma 26. It's 1 here. I should split it such that I have 4 different arrays here. Somehow maybe it needs me to split into 4 arrays because there's 4 different outputs as well. So maybe I should just split it here like that. Train output 0. Okay, I'm just gonna do a shortcut and just do it like that for now. Tuple has no object shape. Isn't there a shape here? Okay. All right. I'll just keep it simple. Simple. All right. I'll just do it like that. Tuple has no object shape. Uh, I have half a mind to just override the entire model function, like what I normally do, because of this silly issue here. Because then I can like define my own loss function myself. Yeah, which then I'm quite sure like it kind of apply in the right area. I thought this could work because the functional API for TensorFlow is supposed to be able to handle multiple outputs. Somehow it's not doing it. It's not doing it in the way I thought it would. Maybe it's the loss function. Because sparse category cross entropy only has one. I'm getting somewhere. Yeah, yeah, it's the loss function. It's the loss function because I did one hot encoding. So one hot encoding cannot use categorical cross entropy. Oh, sorry, cannot use sparse categorical cross entropy, but you can use categorical cross entropy because of one hot encoding. Okay, so I'm getting somewhere. I'm getting somewhere. I think I solved this. So categorical cross entropy is correct. Is correct. The name is this. We can just call it by name here. Okay, what is wrong now? What is wrong now? I'm making progress. Shape none, comma 1, comma 26 and shape none, comma 26 are not compatible. So there we go. Now we activate back our previous thing here. Okay, this one can delete. Go one side. Yes! Holy crap! I'm sorry for swearing, but I mean, it is. It took so long to get it out. Oh, look, the accuracy is 1. So it means that the model has already like sort of memorized which one to go. So let's just see. Okay, if we were to put the model, okay, so what we want to do now is we want to like maybe model dot predict. Okay, a. Okay, but we cannot just do a like that. We need to do like we need to basically map this tf dot one hot thing. Okay, so we need to convert to num. In fact, maybe we could just do this tf1 hot here. No, I think it's fine. We can do the tf1 hot here. So we could actually do the processing here. tf.1 hot. Okay, a dot we should convert this to num. Input 0 is not compatible. Expected shape none, comma 1, comma 26. Okay, let's just see what's the shape of this. Okay, so my model has a input of 1 over here. So I'm supposed to be able to get like supposed to be able to use like a here. So maybe if I just do like a, this is fine. It gives me this, and then over here I'm supposed to be able to predict using this, but they say input 0 is incompatible with model 14. Expected shape none 1, comma 26. Found none, comma 26. So they need me to give in this shape. Maybe I just do a reshape. Okay, simple. I think I just need to put a bracket here. Okay, this is weird. Okay, I mean my shape here is obviously 1 comma 26 already. Then why is it not being able to, to evaluate this? I mean, it's not that difficult, isn't it? Okay, so there's an issue with this, but it has evaluated and predicted successfully with accuracy 1 for just one alphabet. Yeah, let me just try to change this to 4, length 4, see whether this thing works as well. Then I figure out why this thing doesn't work. Oh no, see, 26 or 104 and 26 are incompatible. Oh, 104 and what did they say there? 104 and none comma 26. Yeah, so this confirmed my suspicion. Okay, maybe we cannot do this like that. Yeah, so I'm just thinking that in order for this to work, we need to split this output. Yeah, we kind of need to split this output. Yeah, this is why it's so irritating sometimes. Like you think that TensorFlow is easy with all the preview stuff, but because they obscure it in the training loop, sometimes you just have to bite the bullet and just code inside it. I'm just not too sure why this is an issue because you see now we have 4,26, and if we put the train output here, it's supposed to group into four parts, right? Then it can map to this, unless this thing here doesn't concatenate. But the thing is, if I were to concatenate this, I cannot easily define my loss function, okay, because I do want to do my output separately. Yeah, I'll think about it. Yeah, I'll think about it. I'll probably stream the updated one once I figure out how to do it. Yeah, I have a feeling that I will eventually overload the loss function and just get it out. Maybe I'll overload the entire model function just for the ease of yeah, just to make it easier. Yeah, if not, it'll be difficult to, because now the issue here is I have these four things here that I want to like sort of concatenate or do them separately, but there's an issue right now because my data is of this form 4 comma 26. It's not compatible with this unless I, okay, my idea is to slice them out one by one. So like instead of doing test input, test output, all this, what we can do is we can do test input one, test output one, and so on. So yeah, actually maybe that would work. Yeah, so yeah, okay, let's try to do what I said. Okay, I think that might work. So in the output process, okay, what I do is I will have for I in range 4, Okay, out dot append the output process 0 comma I. Yeah. Okay, the first one is the number, like second one is I, and then yeah, actually I can just do this. For okay, so the output needs to be special. Okay, the output will need to be like I think this would solve the problem. So it's like a manual, like splitting the output one by one using our own function. Okay, so now it's a list already. We don't have a shape anymore. Okay, yes. Okay, that looks promising. That looks promising. Now we have 5 loss functions, and we have 5 tensors. I think this is it. I think this is it. This is it. This is it. This looks good. Okay, so yes, it's able to solve the cipher. I think it has already sort of memorized all the 26 characters and already map it separately to, so you can see that the accuracy is 1 right now, which means that the neural network has already like sort of did a one-to-one mapping from input to the output category, which is pretty simple for a neural network actually, because this is a noiseless kind of cipher and it already decoded it. Okay, great. So we have accuracies of 1 for all of them. Okay, now let's try to predict something. So the train input, let's see how to do the train input. So train input 0. Okay, the tensor is of shape 4. So we need to do 4 comma 26 like that. Okay, what happens if I ask it to predict like test input 0? Input 0 is incompatible with shape 4 comma 26. That's weird. That's weird. I mean, I have 426 in my input because I have this. Maybe I can use this. But even so, if I use test input, it will also be 4 comma 26 the shape. So this should be like that. Yeah, but not sure why this error is here. But I mean, regardless of the error, the training accuracy, I think I solved the issue. Yes, TensorFlow wants me to split my input into arrays like that because of how I define my y here. Yeah, and I define my y here because I have multiple outputs and I want them to use different losses for each of the outputs. So this, at least this part is working. Okay, so right now the only part that's left to do is how to use it to do some prediction. So let's see what I can solve in the next 5 minutes. If not, I'll solve it tomorrow. Okay, let's see. Input 0 is incompatible. Expected shape none 426. Found shape none 26. none for 26. Expected none, comma 4, comma 26. Found none, comma 26. Okay, let's see. Okay, model.predict. Okay. Oh, I need to specify batch size also. I could just use the model. Yeah, I could just use the model directly. I don't have to do predict. So okay, good. Now I got my output. Okay, let's not use model.predict. Somehow that didn't work out that well. Okay, so what I need to do now is I just need to do tf.oneHot. Okay, it convert to num, like maybe the string. Okay, and then I just need to put here like the lengths and the length alphabet. Very good. Now I have the 4 of them here. Okay, which will then mean that I can then take each of this here to like find what's the maximum value. So maybe I can just do it like this. Uh, okay, so I do have A, B, C, D now. So okay, and find the maximum element. tf.math.argmax. Okay, why is everything 0? Somehow the tf argmax doesn't give me what numpy has. Okay, no biggie, no biggie. Yep, we can use this argmax A. Okay, I got it. Maybe I just put like my logits or output logits is this. Or yes. So a string A B C D will get mapped into E F D F G. Okay, so let's try like maybe Z Y X B. Very nice. Okay, so this works out for length 4. Let's try like length 100. Let's just push it. Oh, I think I made the computer jam. Okay, so this is a length 100 string. Okay, all right. Okay, so with a length 100 string, can the neural network learn the right associations? Hey, look at this. It's such a massive neural network. Can the neural network learn the right associations in order to make our string be translated? Okay, so looks like the accuracy is quite low now. Like there's like, okay, but it will take like 2 minutes to train it. Okay, but you see the accuracy is actually gaining bit by bit. It means that actually this is working. I think maybe 10 was a little too much. Maybe let's just try a length 10. Maybe a length 10 would be good enough. This time I make the shift maybe 6. I a bit. Okay, let's try to run it. Okay, okay, so this is more manageable. As you can see, the 10 lost hits, they are actually like training. It's actually learning the Caesar cipher. I think Caesar cipher is quite easy for a network to learn. So maybe next time I'll try to do harder ones like a cipher where you add the first two numbers together or first two letters together or first three, first four, and so on. So like make the patterns a little arbitrary, then let the network try to guess it. Yeah. Okay, but as you can see by epoch 2, the network has associated everything already because there's like 1,000 over examples and there's only 26 characters. So I because I split the output loss per head like this, they just need to learn only the mappings out to 26 characters. So can the neural network learn this decipher or a Caesar cipher? The answer is yes. Okay, yes, it can. Okay, although it took me very long to try to do the splitting like this into the multi losses, like this. In not this, sorry, this one. Yeah, do the multi outputs and then do the multi loss. So it turns out that this train output format, okay, the main thing is that it needs to be also in an array form. Yeah. So yeah, that was something that because in order to match this output, it needs to be an array form. Yeah, something that wasn't that obvious, but yep, I got it. So A B C D A F. Oh, it's a 10, right? A B C D E F G H I J. And with a shift of 6, G H I J K L M N O P. Okay, so I think that concludes today. Yep, neural networks can indeed do some Caesar cipher, and yeah, we'll try to experiment and push the limits of what neural networks can do in the next few streams, right? And yeah, I'll see you around. Okay, bye bye.